Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the constant volume mixing process. We limited our consideration to non-reacting systems, systems whose chemical composition remains unchanged during a process. This was the case even with mixing process during which a homogeneous mixture is formed from two or more fluids without the occurrence of any chemical reactions. A rigid container is provided and built-in plates divided it into n spaces, and n kinds of gases are installed between them. Now, remove all the plates and mix them thoroughly. Such mixing of different gases is irreversible because the mixture forms spontaneously and a work input from the surroundings would be required to separate the gases and return them to their respective initial states. Three factors contribute to the production of entropy in mixing process. 1. The gases are initially at different temperatures. 2. The gases are initially at different pressures. And 3. The gases are distinguishable from one another. The mass after mixing is equal to the sum of the mass of each gas. The volume after mixing is equal to the sum of the original volumes. This mixing process is a process performed in a closed container without expansion work. We have this relation if it is considered that there is no heat exchange between the mixing process and the surroundings. The thermodynamic energy after mixing will be not changed. Assuming that n gases are all gases with constant specific heat capacity, the above formula becomes: the internal energy of the ideal mixed gas should be equal to the sum of the internal energy of each component gas in the mixed state. This indicates that the heat capacity of the mixed gas is equal to the sum of the heat capacity of each gas. After mixing, the temperature is, the pressure is, where the average molar mass can be determined by equation 7.10. The entropy increase during the mixing process is the total entropy increase of each gas from the state before mixing to the state after mixing. If the same ideal gas is mixed, it is calculated according to the difference between the entropy of the gas after mixing and the entropy summation of the gases before mixing. Okay, that's all for this task. Thank you very much and see you next time.